Okay guys, I'm just going to do a very short video for you. I'm just going to work one of these problems for you so you can see how it's done. Just don't even look at this one, this sample. Just go ahead and cross it out. Okay, let's look at this one as an example. So all you're doing on these are called free body diagrams, and all you're doing is adding or subtracting the vectors, okay? You're going to subtract the vectors that go in opposite directions just like you did before, and you're going to add the vectors that go in the same direction just like you did before. These two vectors are going in opposite directions, so you are going to subtract one from the other. This N is newtons, okay? That doesn't stand for north, that stands for the unit. So just look at the numbers. You're going to subtract 3 from 10. So your net force, F net, your net force, which means the total on this one, is going to be 7 newtons, okay? And because there is a net force, that means that the forces are unbalanced, and it's going to move up or to the north. Okay, that's the direction that has the most magnitude. Okay, so that's all you're going to do is state whether or not the forces are balanced or unbalanced, and if they're unbalanced, what direction is the object going to go. When your net force is 0, that is when you have balanced forces. If you have any net force acting on the object, it's not balanced. It's unbalanced forces. All right, so that's how that one is done. Okay, now let's go down to the other problems. Okay, and try and scroll over. These are going to be exactly the same. Okay, you've got the numbers for your magnitudes. Okay, you're going to add the vectors on this one that are going the same direction. So you've got 4 plus 3 is 7 going to the east, and you've got 8 newtons going to the west. So you're going to subtract 7 from 8, and you get 1 newton going to the west. Okay, look at these over here that do not have numbers. Okay, and all you're going to do on these is just look at the size of the vectors, determine whether or not they balance each other out. For instance, this one, all of the vectors are going to cancel each other out, so this object is going to stay balanced and at rest. Okay, this one is going to push up, this one is going to pull to the right, so in essence this object is going to go this direction. Okay, this one is pulling up, this one is going to the right, so it's going to go in this direction. Okay, so you guys are just going to look at the vectors and show the direction that the object is going to go based on the forces. Okay, this is due at the end of class. If you have any questions, ask Miss Merchelar. She'll be happy to help you out. And I will see some of you guys tomorrow morning. The rest of you I will see on Monday.